So hi, this video lecture, let us see how a restoring division algorithm works. So this is the flowchart for a restoring division algorithm. The first step is you have to subtract the divisor register from the remainder, and then the result has to be placed in the remainder register. Then you have to check the remainder. So the most significant bit has to be checked, and if it is 0, you have to do we have to restore the original value by adding the divisor register to the remainder, and the result has to be placed in the remainder register, and the quotient has to be shifted by left, and the new significant bit has to be set to 0. And if it is 1, in that case, we have to shift the quotient register to left, and the new rightmost bit has to be set to 1. After this, the divisor register should be shifted right by 1 bit, and this has to be done for n iterations. So let us see one example, 7 divided by 2. So first step is you have to initialize all the values. So the quotient register should be initialized to 0, the divisor by 2, the binary equivalent of 2, and the remainder, the binary equivalent of 7. Then the first step is you have to subtract the divisor register from the remainder register. So this 7 minus 2 has to be done, and the result has to be stored in the remainder register. Now you have to check the most significant bit, and if it is 1, in that case, you have to shift left Q and Q naught, and then you have to shift the divisor by right by 1 bit. So for the next iteration, again you have to check the remainder most significant bit. If it is 1, then in that case, again you have to restore the original value. You have to add the divisor to the remainder, and the result has to be placed in the remainder. Then you have to shift left the Q, and then Q naught has to be set to 0. Then for the third iteration, again, the MSB of the remainder is 1. So again, you have to do remainder plus divisor, and the result has to be stored in the remainder. And then you have to shift left the quotient register by 1 bit, and then you have to set the LSB to 0 now. So now for the next iteration, the LSB is 0. So no need to add the divisor and the remainder. Now you have to come to this category. You have to just shift the quotient register left by 1 bit. And now we have to set the most significant bit to 1. So you have to set the most significant bit to 1. So this has to be done for n iterations. So now your quotient is 11, that is 3, and the remainder is 1.